Okay, starting with supplementary and going all the way down to, I believe, linear pair. All of those words are names for pairs of angles. So all of those words are ways that we can classify two angles put together. Okay, so if you have two angles and you want to say something special about the two of them put together, that's what these are. So, supplementary, complementary. How many of you felt like you had at least heard those words before walking into class yesterday? Okay, good, good. Really the thing to keep straight here is one of them means the angles add up to 90, one of them means the angles add up to 180. I'm going to show you a little trick that I just read somewhere. If it's helpful to you, great. If it's not helpful to you at all, you're welcome to ignore it. But if you look at the word complementary, okay, and you take that first C and drop a line down like this, do you see that that makes a 90 there? Okay, so complementary angles add up to 90. Okay? Supplementary angles, and again, I don't know how helpful this is to you, but if it's helpful, please use it. This one is a little less instinctual, but usually if you can get the complementary, then you know supplementary is just the other one. On this one, the trick that I saw is if you close off that S, it makes an 8, and then you can use that to remember like 180, okay, for supplementary. Again, maybe that'll help you, maybe it won't, but what you need to know, complementary makes 90, supplementary makes 180, okay? Oh, here's my page here. So for a picture for supplementary, I'm going to purposely draw them like this, but know that your picture might look different than mine, so don't start erasing yours right away. Okay? Say this is 70 degrees, and then I'm going to draw an angle like this that's 110 degrees. Is it true that 70 and 110 together make 180? Okay, so these angles are supplementary. Now, they're not right next to each other. They could be right next to each other, and that might be what you have drawn. If they are right next to each other and they're supplementary, that's when they become a linear pair. If you go down here to linear pair, and again, I'm not crazy about this definition, but if I take that 70 degree angle and that 110 degree angle and put them right next to each other, okay, that makes a linear pair. I could still call those supplementary. If I asked you to draw me a picture of supplementary angles and you drew me that, that would be okay. But I want you to see that they don't always have to be next to each other. So let's talk about linear pair for a minute because this definition is confusing. The other thing I found, second hour, is some of the websites that people have used, the definition they give for linear pair is different. They give a definition that really is the definition of vertical angles. And I don't know if it's that different textbooks define things different ways. Sometimes that happens, but just be careful of that. Linear pair is two adjacent angles, and we'll come back to that adjacent thing in just a second. And I guess I'm okay with all of this. The non-common sides, that means not this side here that they share between them, but like this side and this side. What I want you to know more than I want you to know that they make opposite rays, I want you to know that they make a straight line. Form. Because that's why they're called a linear pair. See how that the pink side and the blue side together make one straight line? That's why they call that a linear pair. Okay? Clayton?
On Google it said like the definition was a pair of adjacent, like, and then comma, supplementary.
Okay, which is this, so adjacent, and then supplementary means that they add up to 180. Is it true that there's 180 degrees in a line? So that is an accurate definition, yes. I'm trying to think on your quiz if that would mess you up. No, I think as long as you knew that, that'd be fine. So adjacent supplementary angles, I like that too. So you could also just know that they are adjacent and supplementary. Okay? Because if they're supplementary, then they automatically form a straight line, because a straight line is 180 degrees. Okay? So now that we've used that adjacent word a couple of times, let's talk about adjacent angles. And all of this is, okay? That's an ugly definition. What does the word adjacent mean? You know? Keegan?
You mean like next to?
Next to, yeah. It's angles that are next to each other. And not just next to each other, but they usually, or no, they always share a side. So they're next to each other. And they share a side. I know this is going to be hard to see. Okay? Angles that are next to each other and share a side. So if you look down here at this linear pair that I drew, see how this angle and this angle, they share this side? That's what makes them adjacent. They don't have to be a linear pair to be adjacent. It could look like this. Okay? This angle here and this angle here, those are adjacent because they share this side in the middle. They're right next to each other. Okay? Does that make sense? Kind of working my way back up. Let's head over to complementary, and then we'll get to vertical. Okay? Complementary, same kind of thing as supplementary, except this time your angles are going to add up to 90. So if you had a 42 degree angle and a 48 degree angle, that's probably a lot more than 48, but those two angles add up to 90, so they're complementary. Now what you may have seen drawn, if you looked up this picture someplace else, if I made that so those were adjacent, if I made it so that those angles were next to each other, it would look like this. You would have a right angle and this kind of sticking out here. So like here's your 42 degrees, here's your 48 degrees. So you can make them adjacent, you don't necessarily have to. By the way, that reminds me, I think we missed a symbol back on that front page. We skipped over right angle, but we didn't do the symbol. Do you know what the symbol is on a picture for right angle? Yeah, it's like a little box. So if this is your angle, you put this little box in the corner, and that tells me that that's a right angle. Okay? Like the arc? No, you don't have to. Nope. Just as long as you know this is your angle and this little box means it's a right angle. Okay? You are going to find this year, my artwork is terrible. When I draw pictures on the board, they're going to be ridiculously bad. Okay? You can make fun of me. It's all right. I know they're terrible. The wonderful thing about geometry is that you have to believe me. If I mark it with a symbol, even I could do this. I could draw like an angle like this, and I could say, oh, that's a right angle. We'd have been so much more impressed. Okay, I could draw an angle like that. And if I put that little box in the corner, you have to believe me that that's a right angle. Even though you're looking at it and you're going, oh my gosh, I can't believe she drew that. Okay, so that's the good thing about these symbols, is that if I mark it with a symbol, even if you're saying there's no way that's congruent to that, if I mark it and say this is congruent to this, you have to believe me. I love geometry for that reason. Okay? All right, let's talk about vertical angles, because this is possibly the most offensive definition on this whole page. Blah, 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 blah. It's correct, okay? It's technically a correct answer, but not one of us in here is going to read that and be able to picture what vertical angles actually are, okay? Vertical angles are not adjacent, so they're non-adjacent, but they are congruent. And we're going to get to congruent in a minute, but what does congruent mean? The same or equal. Good. Non-adjacent congruent angles, I'm abbreviating here, formed when lines cross. And the word vertical angles is a little misleading, okay? Because they're not always up and down. I know you think vertical means up and down, and it does, except with vertical angles, it doesn't have to be. So when I have two lines that cross like this, these angles are vertical, okay? See how they're across from each other? They're not right next to each other. They are congruent. So those are vertical angles. And that's what you would think of, right? Because you're thinking up and down. Technically, though, these angles are also vertical angles, all right? Anytime they're formed across from each other when two lines cross, okay? So anytime you have two lines cross, you're going to have a set of angles going one way and a set of angles going the other way. And each one of those pairs is called vertical angles. Does that make sense for vertical angles? Was that one that you had not seen before? Or have you talked about those before? Did you walk in yesterday knowing what vertical angles were? No? Okay. Okay, let's talk about congruent. We just said that. Congruent, this is actually a pretty good definition of congruent. The really big thing that I want you to know is that they're the same size and the same shape. And all this is saying is, like, if one of your triangles is drawn like this, and one of your triangles is drawn like this, if I could take this triangle and flip it around and lay it on top of this one and they would match up, they're still congruent. So they don't have to be pointing the same way, but they're still congruent. So you can have congruent shapes, you can have congruent angles. Okay, so these two angles are congruent. You could have congruent segments, which are segments that have the same length. And you mark those on a picture with these little dashes or little hash marks. Okay, those are all congruent. Anyone know the symbol for congruent? It's kind of like equals. Jared, you know? Nope, that means not equal. Clayton? Yeah, it's like a squiggle up here. Yep, that's congruent. So that's like the geometry form of equals. Okay? And you use equals when you're talking about numbers. You use congruent when you're talking about shapes or lines or angles, something like that. Okay. Midpoint. The point on a segment equidistant from the segment's endpoint. Actually, I'm going to